All right, folks, here's an interesting one. It's a bit much, but you got to hang in there. You're going to be able to do this. You just got to take it one step at a time. This is everything that I want you to be able to do for this week. This is why we started with lines. If you are able to do this, you are ready for the next step that brings us closer to calculus. Because that's what we're in pre-calculus here, right? So we're trying to figure out how to get ready for calculus, right? Here's what it says. It says, identify the points on the graph of this function on the interval from -1 to 5 where the delta x is 1. You already know how to do that. You did that in the video a couple times ago. Write the functions for each line connecting each of the consecutive pairs of the points identified. In the last video, remember you were given 2 points and you had to write the equation of the line that ran between those 2 points. Well, here you're going to have several pairs of lines, okay? And you're going to have to write the equation of each line that connects each consecutive point. And I'll show you what I mean by that in just a minute. And then it says, be sure to include the domain limits. Lastly, graph the lines. So you want to take all these lines and you want to graph them on a coordinate plane. And we're going to do all of that right now. If you work along with me and if you practice this, if you go back and maybe do this a couple times, you're going to be really good at this and you're going to be really happy that you have a good, strong mathematical skill that gets you ready for calculus. Okay? All right, so here we go. First it says identify the points on the graph of this function on the interval from -1 to 5 where delta x is 1. Well, what are all the x values that start at -1 and end at 5, right? And where our delta x is 1. Well, we got -1, and -1 plus 1 is 0, and 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, and 4 plus 1 is 5. So here's what we're going to plug in. -1, 0, 1, 2, 3, 4, and 5. Okay? That's going to give us 1, 2, 3, 4, 5, 6, 7 points. Okay? So here we want to identify f of -1, f of 0, f of 1, f of 2, f of 3, f of 4, and f of 5. Okay? So we're going to plug these numbers into this function here, and we're going to get some output values. So let's start with -1. Well, you can use a calculator for this if you need to, but I'm going to do it just by talking it through. -1 squared. -1 times -1 is +1. Actually, let's write this out. We got -1, so f of -1 is going to be equal to -1 squared. Notice I put it inside parentheses. -1 squared minus 4 times -1 plus 1. -1 squared is 1. -4 times -1 is plus 4 plus 1. Okay, so -1, or f of -1 is equal to 6. 1 plus 4 plus 1 is 6. So f of -1 is 6. All right. Now we're going to plug in 0. 0 squared is 0. -4 times 0 is 0 plus 1. 0 minus 0 is 0, plus 1 is 1. So f of 0 is 1. Okay? All right, now let's plug in 1. All right, 1. 1 squared is 1. -4 times 1 is -4 plus 1. 1 minus 4 is -3, plus 1 is -2. So f of 1, that's -2. All right, now let's plug in 2. Oh, I keep changing this. I should have made this a 0 and then a 1. Now it's a 2. F of 2 is 2 squared, which is 4. -4 times 2 is -8 plus 1. 4 minus 8, that's -4. -4 plus 1, that's -3. So f of 2 is -3. Now we're going to plug in 3. Put a 3 here, put a 3 here, put a 3 here. Remember, we're plugging these into x squared minus 4x plus 1. X squared minus 4x plus 1. And when x is 3, we put a 3 here. 3 squared, that's 9. -4 times 3 is -12. plus 1. 9 minus 12, that's negative 3, plus 1 is negative 2. So f of 3 is negative 2. Now let's plug in 4. All right, 4, 4, 4. 4 squared, that's 16. Negative 4 times 4 is negative 16 plus 1. 16 minus 16, that's 0. Plus 1, that's 1. So f of 4 is 1. Now we're just going to plug in 5, and we'll be done. So f of 5, 5 squared minus 4 times 5. 5 squared, that's 25. Negative 4 times 5 is negative 20 plus 1. 25 minus 20, that's 5. 5 plus 1 is 6. So f of 5 is 6. So here's all the points that we have. We have the point negative 1 and 6. We have 0 and 1. We have 1 and negative 2. We have 2 and negative 3. We have 3 and negative 2. We have 4 and 1. And we have 5 and 6. Okay? So we've identified all these points. Identify the points on the graph of this function on the interval from negative 1 to 5 where delta x is 1. All right? So we identified all the points starting at negative 1, ending at 5, and we went every one. So x changed by 1 each time when we plugged in a number. So we have 7 points here. So now it says, write the functions for each line connecting each consecutive pair of points. So what that means is this is, here's a pair, the next consecutive pair are these two. So there's negative 1 to 0, then there's 0 to 1, then there's 1 to 2, then there's 2 to 3, then there's 3 to 4, and then there's 4 to 5. So that's 1 line, 2 lines, 3 lines, 4 lines, 5 lines. That's 6 lines that we have to write 6 line equations. That means we need 6 slopes and we need 6 functions. Yeah, I know it's going to take a few minutes, but we're going to be able to do it. If we're patient, we can do this. We know how to do 1, so we know how to do 6. It's just going to take us some time. So let's start with this one here. We want the slope between these 2 points. So m is going to be equal to y2, 1 minus y1, 6 over x2, 0 minus x1, negative 1. 1 minus 6, that's negative 5. 0 plus 1, that's 1. So that means that the slope is negative 5. Now, point slope form, let's pick this negative 1 and 6. So it's going to be y minus 6 is equal to the slope, negative 5, times x minus negative 1. So that's x plus 1. Now we're going to turn it into slope-intercept form. So we're going to distribute the negative 5. We'll have y minus 6 is equal to negative 5x. Negative 5 times 1 is negative 5. Now we're going to add 6 to both sides. And we get y equals negative 5x plus 1. So that's our first one. Over here, we'll write it right here. So actually, you know what? We'll write it over here because we're going to graph them in a few minutes. So let's start up here. We'll have y equals negative 5x plus 1. And then we have to put a comma, and we have to say that x is between negative 1 and 0. Negative 1 and 0. In fact, we can go ahead and draw this line now if you want to. So we've got the line negative 5x plus 1. All right, plus 1 is right here. Negative 5 means down 5, 1, 2, 3, 4, 5, and over 1. So that means it'll go here. The problem is that we only want it to go between negative 1 and 0. So really we should go backwards from here. Instead of going down 5 and forward 1, we should go back 1 and up 5. 1, 2, 3, 4, 5. Put a dot there. And really, you know what we could do, I don't know if you noticed this, these are the points -1, 6, and 0, 1. -1, 1, 2, 3, 4, 5, 6, and 0, 1. So what we could do is we wrote the equation of the line, but all we really have to do is plot these 2 points and draw a straight line between them. So we'll take this thing, line up the lines, and we're just going to draw a straight line between them. There we go. That is this line right here. Okay. All right, let's move on to the next line. That's line number 1. We got 6 of them to do. So we did here to here. Now we're going to do from here to here. So our slope is going to be y2, -2, minus y1, which is 1, over x2, 1, minus x1, 0. -2 minus 1, that's -3. 1 minus 0, that's 1. So our slope is -3. Point slope form, let's use 1 and -2. Y minus -2, that's y plus 2, is equal to the slope, -3, times x minus 1. There we go. Now we're going to distribute. We want to turn this into slope-intercept form. So y plus 2 is equal to -3x. -3 times -1 is plus 3. Now we're going to subtract 2. We're going to get y equals -3x, and 3 minus 2 is plus 1. So here's our second equation. Y equals -3x plus 1. And the interval is starting at 0 and ending at positive 1. So we're going to say 0, x is greater than or equal to 0, but less than or equal to 1. And the points are 0, 1, right here, and 1, -2. 1, -2, right here. So now I'm going to line that up and draw a straight line between these 2 points. There we go. All right. Now let's do the third one. Okay, now we're going to draw the line that goes between 1, -2 and 2, -3. Okay, so we need a slope. So our slope is going to be y2, -3, minus y1, which is -2, making it plus 2, over x2, 2 minus x1, 1. So -3 plus 2 is -1, 2 minus 1 is 1, giving us a slope of -1. These are our 2 points. So we'll do point slope form. We'll use this point right here. Y plus 3 is equal to the slope, -1. So we'll just put negative x minus 2. So the equation of our line is in point slope form. And now what we want to do is we want to put it into slope-intercept form. So we're going to distribute the negative. So we're going to have y plus 3 is equal to -x. Negative times -2 is plus 2. Then we'll subtract 3 from both sides. And we'll get y is equal to -x minus 1. Okay, so we'll have y equals -x minus 1. And it's going from 1 to 2. So we'll go 0, or excuse me, not 0. I'm putting a 0 for there for. I was looking up at this one right here. We're going to go from 1 less than or equal to x less than or equal to 2. Okay? And we're going between the points 1, -2, which is right here, and 2, -3. 1, 2, and -3, which is right here. So we're going to draw a straight line from there to there. I'm not going to use the, it's only a little tiny line there, so I'm not going to use the ruler. All right, now, we're halfway done. We've got 3 out of the 6 lines done. So now we're going to do the line that goes between 2, -3 and 3, -2. So we need a slope. M is equal to y2, -2, minus y1, -3, which is plus 3, over 3 minus 2, x2 minus x1. Well, -2 plus 3, that's 1. 3 minus 2, that's also 1. So we have a slope of 1 here. So point slope form, y minus, let's use this one, y minus -2, which would be y plus 2, is equal to 1, so I'm not going to put it, x minus 3. And now, because I don't have a slope out here, I don't really need these parentheses, so really it's just y plus 2 is equal to x minus 3. So now we'll subtract 3, or excuse me, not 3, subtract 2 from both sides, cancel, and we get y equals x minus 5. Okay, so we'll go y equals x minus 5, and that's going to start at 2 and go all the way up to 3. And then it's going to connect the points 2, negative 3, and 3, negative 2. So 1, 2, 3, negative 2. Look at that. Draw a straight line here. There we go. All right, we just have 2 lines left. Just 2, 3, 2 more lines. Just 2 more. Okay, so we get rid of this. Now we want to do the line that goes between 3, negative 2 and 4, 1. So we need a slope. M is equal to y2, 1, minus y1, which is negative 2. So minus negative 2 means plus 2, over x2, 4, minus x1, which is 3. 1 plus 2 is 3. 4 minus 3, that's 1. So we have 3 over 1, which is 3. So our point slope form is going to be y minus, let's use this point here, y minus 1 is equal to slope of 3 times x minus 4. Now we'll distribute the 3. We'll have y minus 1 is equal to 3x minus 12. Add 1 to both sides. We get y equals 3x minus 11. Okay? So y equals 3x minus 11 on the interval from 3 up to 4. And it's between the points 3, negative 2, which we've already plotted, and 4, 1. So 1, 2, 3, 4, and 1 right here. Let me set this line up and draw a straight line. Right, that's not quite right. There we go. Right there. There we go. Now we've got 1 line left to draw. All right, we're doing the line that runs between 4, 1 and 5, 6. So we need a slope. y2, 6, minus y1, 1. x2, 5, minus x1, 4. 6 minus 1 is 5. 5 minus 4 is 1. Have you noticed that every single time our denominator has been 1 when we've calculated our slope? Do you know why that is? It's because of this. Delta x, change in x. Remember, the slope formula is y2 minus y1 over x2 minus x1. Well, we also call this change in y over change in x. Well, change in x is 1. So every single time we have done this, we've gone from one to the next, the change in x has been 1. That's because the change in x in the problem was said to be 1. That's why that's happening. Just wasn't sure if you noticed the pattern or not. All right, so the slope is 5. So we're going to do point slope form. We'll use this point. Y minus 6 is equal to the slope of 5 times x minus the x value of 5. And so let's distribute the 5. We got y minus 6 is equal to 5x minus 25. Add 6 to both sides. And we get y equals 5x minus 19. And so our final, our sixth one, the sixth line, because it says for each line connecting, write the functions for each line connecting each consecutive pair of points and include the domain limits. Well, we've been including the domain limits the whole time. 5x minus 19, and this is where x takes on a value somewhere between 4 and 5. Okay? And now we're going to graph that one, and it connects the points 4, 1, and 5, 6. Well, here's 4, 1. Let's go to 5, 1, 2, 3, 4, 5, 6, right there. And then we will get a ruler here, line them up better than that. There we go, and connect them. And there we go. You know what you're looking at there? That is the linear a kind of linear approximation graph of this quadratic, x squared minus 4x plus 1. That's an approximate sketch, a linear approximation drawing of the graph of x squared minus 4x plus 1. Okay, that's what you're doing. That's what it is that I want you to, what it is that I wanted you to learn how to do. I wanted you to learn how to take a curvy graph and draw it with a bunch of straight lines instead. If you can do that, and if you can understand how to write the equations of all the lines, you've got a very good skill, and you'll be really ready to learn calculus. Okay, that's all I have for you for this one. I'll probably give you maybe about 4 of these, just so that you can get a good feel for it, and I'll see you in class.